Okay,
Yes,
recording.
We're gonna.
It's recording. Good.
We're all gonna
Okay.
Let me go back.
Silence so we can hear better.
Shh.
So, question is, where does this formula come from? What does it mean? So basically this formula says that there's a difference in pressure between 2 points, vertical points in a fluid. Okay? And the difference in pressure between these 2 points is the density of the fluid times g times the distance, the vertical distance between the points. So if I have 2 points in a fluid, you know, this is the bottom point, this is the top point. Okay, basically the pressure over here is going to be lower than the pressure down here. The deeper you go in the fluid, the higher the pressure. That's what it says. Okay, so I'm going to say this is the pressure at the top, this is the pressure at the bottom. Okay, the way you understand where this comes from is to look at some random column of fluid. Okay. So this column has a cross-sectional area A, okay, and a height h. Okay. Now, to understand why it comes out like this, you basically draw a force diagram
Of what?
for this
For the
column of fluid.
Force diagram for the column, right?
So, what are the forces acting on this column of fluid?
Force of the earth.
There's the force of the earth, that's the easy one.
Yes.
The force of the air above and below the middle of the
And the
particle.
force of the earth. Air.
Here.
Yeah.
Force of the air.
There's no air.
Wait.
The force of the
Just in
barometer.
the middle of a fluid.
What
Any
is that?
fluid.
Is that an air column?
Yeah, column of air.
So
The force of the
Which one is-
barometer. No. No.
the column itself on the earth. Oh no.
The force of
Yeah.
the air,
Jesus is air.
air above.
Air above. Which way is the air above pushing? Down.
Down.
Okay. So there's
Oh, is it
There's
cylinder?
okay. So all the air above this is pushing down.
Because it's a cylinder.
No.
No.
Yeah.
Doesn't matter what shape it is.
Okay.
Okay. Whatever it is, there's air pushing down.
Okay.
And so I can say the force of the air on the top,
On the
okay,
column.
on the fluid column is equal to the pressure at the top times the area. Yeah? Okay. So this is pushing down. This is the force of the air above on the fluid. And how about down here?
What?
The force, the same
What's
thing.
holding the column up?
The force of the air,
Below.
The perpendicular.
below.
which is the pressure.
It's pushing.
There's pressure here
It's pushing up.
pushing up. Yeah?
Well, what's holding the column?
The air pressure down here. I'm looking at any random column. I start here and I finish up here.
Oh, okay, floating.
Yeah, floating, right? It's floating.
Okay, okay. Yes.
Okay.
And the air.
So
Pushing up,
then
yes.
there's the force of the air below
That equals the two forces
Yes.
going down. In
Which
order
is
for it
pushing.
to keep up.
on the fluid, which is pushing up, and this is equal to the pressure at the bottom. The force of the air below is equal to the pressure at the bottom times the area. That's its definition of pressure. Yeah? Pressure is the ratio of the force per unit area.
Mm-hmm.
So this is equal to pressure at the top times area. This is pressure at the bottom times area. So then I just write it out. Pressure at the bottom times area is equal to pressure at the top times area plus the force of the earth on the fluid. Newton's second law. Equilibrium. Forces up equal forces down. Yeah?
Because the column is like this.
Where's the eraser?
Yes.
There it is. So, now it's just a matter of working it out. Pressure at the bottom times area equals pressure at the top times area plus the mass of the fluid times G. Yeah. Pressure at bottom times area equals pressure at the top times area plus mass of the fluid is equal to density of the fluid times volume times G. Pressure at the bottom times area equals pressure at the top times area plus density of the fluid. Volume is area times height times G.
So the volume is the area times the height times G.
No.
The
Times the
air times G.
Oh,
And G is the gravity.
AH, alright,
Yeah.
the volume. And
And?
the mass is equal to the
Density is mass over volume, so mass is volume too.
Pressure at the bottom equals pressure at the top plus density of the fluid times G times H.
H.
That's it.
so that's the pressure at the bottom.
Yes. Well, the difference in pressure is equal to root GH.
Okay. Got it. Wait, how did we incorporate height in there?
Yes.
From the third? No. Coming from when you first included density times volume. Oh,
The volume is area times height. That's it.